Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the use of power collections within your application. I've set up a small common library to allow us to display information on the screen from a program regardless of whether you're using the Windows or the console compiler. In the application we're going to be using today, we're going to reuse a comma-separated variable file we prepared in an earlier video. This small file contains a number of records holding the first name, surname, address, telephone number and account number. The code I prepared earlier quite simply takes this CSV file and uses one of the common library routines we prepared in an earlier video to load it into an array, strwork. What we're going to be doing today is to manipulate this array and put it into a power collection. So the first thing to do at the beginning of our program, we're going to create a user-defined type. This user-defined type, you customers, is going to contain the fields, the account number, the first name, the surname, the address and the telephone number. So how do we set up a power collection? The first thing we need to do is we need to set up a local variable as a power collection. This is one of the inbuilt features of PowerBasic that is very powerful. Having prepared our local variable, customers, which is the power collection we're going to be putting data into, we'll want to prep our local user-defined type. So what we're going to be doing, we're going to take the data that's in the array, strwork, and we're going to put each record in that array into our user-defined type. So we're going to set up a simple for next loop. And within that for next loop, we're going to pick up the account number, first name, surname, address, and telephone by using the parse command to parse out from the element of the array the individual parts we're actually interested in. So this would populate the user-defined type. Now what we want to do next is we want to look at how we can actually take the information that's within that user-defined type, which at the moment is just a single record, and we want to put that into our newly created collection. So the first thing to do is to add our customer record to our brand new collection. Now we need a new variable called wkey. Now wkey is going to be a Unicode string. So we'll set that one up at the top here. Now this key is going to be the unique identifier of the record within our power collection. So we're going to make that the account number. So we're storing the account number in wkey. How do we go about adding that to our power collection? Now, the customer's add method will add our data to the collection. We have to give it two parameters, one being the key, our unique identifier for the record, and the second parameter is going to be a variant. Now, our user-defined type is not a variant, but what you can do, PowerBasic does quite a lot of the heavy lifting for you here by using asString. So what it basically does, it takes the entire user-defined type and it places it inside the collection as a wide string. So now that we've given the add command, how do we know it actually worked? Well, we can use object result to work out whether it's okay or not. it's important to test the output from object result, because as the key has to be unique, you can't put the same key in twice. If you attempt to add the same key on the second attempt, it will error. So, having done that, let's run our code now to see what it does. Oh, we haven't declared a long R. And there we go. If we have a look at the data, we can see that it has indeed recorded each of these account numbers into the collection. Now they're not sorted in any order in the collection, but we can give a command to quite easily sort the data. Having put all the data in, you may want to check to see how many records have actually reached the database. And you can use the customer's count method for actually doing that. Now, as this is a number, we'll use the format command to turn it into a string so we can display it on our log. And what we will also do is we will sort the collection. So if we run our code now, there's our records going in, and it is confirming it did actually find 8 records. So that gets the data into the collection. How do we know it's actually there? Well, one way would be to read it back out again. So how can we get the information back out of the collection in a format we can actually see? Well, just to prove we're actually doing this correctly, I'm going to set up another user-defined type. We'll call this one customer out. So, if we were reading from an array, you would use a for next loop. Since we're reading from a collection, we do something very similar by using for each. Now the data we take out of the collection needs to go somewhere. And what we need to do is set up a variable to store each of those records. And we're going to use the variant variable type. And we're going to put our data into a variable called vdata. So for each record in the customer's collection, we're going to put the data within that record into vdata. Now that's all very well, but how do we actually see what's in vdata? Well, we can use the type command for that. And we're going to be putting the information into our customer out user-defined type. And we're making that equal to vdata, but we can't set vdata directly into customer out because vdata is a variant and customer out is a user-defined type. However, PowerBasic does give you a nice easy way of translating these, like so. This will quite easily take the information that's in vdata, convert it into a user-defined type. From within our user-defined type, we can then display the information quite happily on our log. So all we're doing here is we're taking the customer out user-defined type and the account number. Since this is a user-defined type, we're using a trim command to trim all the extra spaces on the end out. And we're adding on the first name, the surname, the address and the telephone. So if we ran this now, we would see at the end we now have the same information coming back. If we just compare that to our original file, we find that the data has not only been stored in the collection, it's even been sorted into account number order, as we issued the sort method. So we have our 8 records, which we have taken from the file via an array straight into our collection. So we can actually store the data in memory, but can we update it? Can we remove records? Can we add records? Let's try adding a new record to our collection. So, in here where we've actually added each of the 8 records, we display a message to say how many records we've actually found. What we're going to do in here is we're going to add a brand new record to the collection. We take the same approach as we did before. We're going to set up a W key, and we're going to put the data into that. So what we'll do first of all is we will prep our user-defined type to contain all the information that we want to put in. So we're putting a new record of account number 1300 for Fred Smith at 12 Anyplace, Any City with their telephone number. Now their W key in this case is going to be the account number. This will be our unique record within the collection. And just as we did before, where we used a customer's add, we will use the same command again to add a record. Since our data exists within UDT, we can then push it into the collection as a string. Again, we'd want to double check to make sure that the record is not already in there. So we can use our object result again, which tests to see if the command on the previous line was successfully executed. Now, having done that, we might want to check to see how many records have actually been found now, since our record count should have gone up by 1. So we'll print out, using the count method, how many records I've actually found in the database. We will then do the sort, and then we will display the records back out to our log by pulling it out of the collection. So if we try running that code, we'll see the original information coming up. We'll see there were 8 records in the database at that point. We have now stored our new account number 1300, and it's now telling us there are 9 records in the database. And 1300 has been sorted for Fred Smith in with all the other records. So we can quite happily add a new record to our collection. Can we remove one? Well, if we want to remove a customer, let's put some code in to do that. Well, we'll want to actually identify which customer we want to remove. Well, let's have a look. Let's say we want to remove this line of data. Now the account number is 1200, so we will set our W key to 1200. Then quite simply we use the remove method. It takes a simple parameter of the W key, the unique reference. And again, just as we did before, we'll want to test if that was a success or not. Because if we give it a W key that doesn't exist, object result will not return OK. So what we can also do, just to see how many records we've got left in the database, if it's successfully removed, we'll put a message out to the log to say what the current count of customers in our database is. And again at the end we'll sort it and display it. So what we should see is we should see no entry for account 1200. So if we run that now, we'll see it was 8, it went up to 9, account 1200 has been removed, and it's gone back down to 8 again. And in our list of records, account number 1200 is no longer there. So we've added and removed a record. Can we update one? Well, let's have a look in here. Now, if we look at the records we've got, we have a record number 600 in here. And say, for example, we want to change some, but not necessarily all of the values for that particular account. Say for example this customer has changed address and telephone number. So since we know the account number, we will set our W key to be that number. There are a couple of ways of actually performing this. What we'll do first of all is see if we can actually find this record in the database. Now we'll create another variable up at the top of our code as along. This is going to be our record number of the item in the database. And we're going to use the contains method to pull back that record number. Now if the record number comes back as 0, then the data has not been found. If the record number comes back as greater than 0, then we have actually found the data. So if we've actually found the data, what can we do with it? Well, one thing you can do, quite easily having known the record number, is you can pull back the data. And we can put this into a variant. We can pull back the entry based on the record number we got back, and it will give us two output variables from this call. It will give us the unique key of the record, and it will give us a variant containing the data held within the record. Now that's fine, but you can do it faster. The customers contains is a very useful way of finding out whether the record already exists within the database, so that could be used before you add one, or just to see whether the record exists at all. Another easy way of getting the data without having to use the customer's entry method is to use the customer's item, because you're much more likely to know what the key is. We know the account number for this particular person is 600. So if we do vdata equals customer's item 600, then it will automatically pull all the data in one line of code back and put it into the variant. Now, assuming that there is no problem with that, our object result should return OK. Otherwise, it would not be able to find the record. So this is a very easy way of pulling back the data. And just as we did down here, we can convert what is in vdata back to our user-defined type. And once you have it in the user-defined type, it's a very easy method for actually updating the data. Now I'm just using the prefix command here to save a wee bit typing and to make the code look a little tidier. So we said we were going to update two pieces of information. Now for this customer number 600, they have a current address of 146 Main Street, Hopetown. So that is our address element. And we also wanted to change the telephone. So what we'll do is we will change the street name and the number, and we'll give them a different telephone number as well. Now, having updated the UDT, how do we get that back into the collection? Well, there's a replace method for our customers collection, and it takes, as before, two parameters: the W key, which is our unique reference to the record, and it also takes in the name of our user-defined type as a string. Now, like everything else, we can test to see whether that worked or not. If it worked, then our account has been updated. So what we're doing there is, since we know the account number, which is our unique key, we're pulling the information back using the customer's item method into the vdata variant variable. If that is successful, then we're converting our vData into our user-defined type. We're then updating the user-defined type with the information we're changing, and we're then using the replace method, giving it our unique key, and effectively passing it the data that exists within the UDT as a string. So we try running that now. We will see that our account has indeed been updated, and if we compare that against the original information, for account 600 we had 146 Main Street. If we look at account 600, it's now changed to 126 Main Crescent, and the telephone number has changed as well. So what we've done today is we've successfully taken data which exists in a flat text file, we've loaded it into an array, and from that array we've populated a collection. We can sort that collection based on our unique key, we can pull information out of the collection by the unique key, we can remove it from the collection using the same key, we can also update it. So that gives us the main functions you would find in a small database. Since the collection exists entirely in memory, the access times are very low. So this has been a small introduction to what you can do with Power Collections. That's it for today. Thank you for watching.